Okay, let's talk about the conservation of energy, where if energy is not gained or lost, where on earth did it go? So, law of conservation of energy states that energy cannot be created or destroyed, just changed to a different kind. And I've got a few examples right here where you can see this first one, ice cream, you eat it, and you're going to convert that chemical energy into the energy of motion. Sometimes the radiant energy from the sun can be converted into chemical energy through photosynthesis. Sometimes the chemical energy of gasoline can be converted into the kinetic energy of motion, or sometimes just straight up electrical energy from your outlets can be converted into thermal energy, like with a toaster. Light to chemical, electrical to heat, chemical to mechanical, more chemical to mechanical, though obviously don't switch the gasoline and the ice cream. But I want you to draw at least two of these in your notes, the conversion of one type of energy to a different type of energy. Pause right here, pick any two that you want, and draw them into your notes. All right, so examples of conservation of energy, by the way, it's in parentheses, so don't write this. The total energy in the system will remain the same, even when it's converted. So here I have someone throwing the ball up and down. So right here, it has the maximum kinetic energy. It is moving the fastest and the least potential energy because it's, lowest. As it gets to the top, the kinetic energy essentially zeroes out because it's not moving, but the potential energy is now at its maximum because it's highest above, most gravitational potential energy. And then as it goes down, it's going to be reconverted from potential back into kinetic. The total energy should remain the same. If you're biking up a hill, if you're coasting up, you get to the top, you have lots of potential but no kinetic, and you go down and all that potential turns into kinetic. The total amount of energy remains the same. This is, get it? Physics, not physics. If you've seen The Princess Bride, you get it. But potential energy being converted into kinetic, you should really see that movie. It's a classic. All right, so during this pole vault here, a guy is going up and over the bar. We have energy conversions. At the beginning, he starts by running. That type of energy is kinetic energy. Next up, that pole bends, and that's a type of potential energy. That's our elastic potential energy, which we were talking about before. Finally, the vaulter is raised to the highest point. That would be the gravitational potential energy. So he starts kinetic, elastic potential as it bends, and then it brings him all the way up to gravitational potential energy as he goes up and over the bar. Here you can see another example of that kinetic being converted to elastic, being converted into kinetic right in that ow face. All right, enough of that. Here's that same guy before that I've shown. Here you can see those energy conversions as they happen. I love how stubborn he is. But we start with kinetic, elastic potential, gravitational potential, elastic, and back to where we started with kinetic. All right. When you have the friction small enough, the total mechanical energy does not change. So the way we're going to write this, the kinetic and potential at the beginning is going to be the exact same as the kinetic and the potential at the end. So here we have a pendulum swinging back and forth. Here it has the maximum potential energy, but the least kinetic because it's not moving very far. Here, again, same as before, maximum potential energy, zero kinetic. Down here at the middle, least amount of potential energy because it's at the bottom, but that's when it's moving the fastest. So here we have Neil deGrasse Tyson demonstrating the conservation of energy, and the energy that it starts with cannot possibly exceed the energy that it ends with, which is why he's not going to actually get hit by it. Here's another one here, a guy at MIT. It swings. He's confident it's not going to hit him. Oh, except it's Miley Cyrus. Never mind. Anyways, conservation of energy and friction. Friction will change kinetic energy into a different type of energy. Friction slows things down, and it converts movement into heat. Have you ever seen brake pads that get overheated because you're trying to slow a car down too much? So anytime you have machinery, friction reduces the efficiency. It's also a huge cause of energy consumption in cars and factories. So in a lot of cases, a lot of falling potential energy is converted to thermal energy. But the total amount does not change. You can't create energy, you can't destroy it. All that happens is it's going to be changed to a different type of energy.